Yeah, there's a artificial intelligence class offered for a senior level class. You could take it at you can take it for your senior elective. It's cool. It's a really cool class. It's a really good intro to AI. I would recommend it. It's be ready to do. So if you take it with Dr. Fasley or Professor Fasley, I will say just don't worry too much about getting a perfect score on all the homework. The grading on it is very easy. Or the grade curve in that class is very forgiving. He has like the spread of the grades set lower. So like getting a 50 is like a D. So like unless you like literally just don't show up, you can still pass the class. Don't worry about like getting perfect scores on the homeworks. Even if you just get a few points on each, still send it in for sure. But anyways, I digress. Let's get to our stuff because we have a lot to go over. So you guys, I believe, had the ATM lab was due today, right?
Oh, also just FYI, the Chapter 12 pre-lab is off by a year.
Is
The
it?
turn-in date.
Don't worry about it.
Okay.
We won't do a late penalty for that, I guess. So just turn that in. Turn that in before I get final grades in. Um, so here is our lab. And I wrote this last year, so I do need to read it to refresh myself. This is you're building out three options: sign in, show customer list, and exit. The user chooses the second option. The program should output meter happy customers, and then 3 customers max on each line. Okay, so here is how we are going to do this. A different customer class that has all this stuff. All right. So the easiest way, whenever we're building anything, and the reason why I wrote this lab out the way I did, is to encourage you guys to uh, the easiest way to start these things is to just start out by creating the basic classes, and that's when I go to doing the like the main big demo for today. I'll kind of show that off. Uh, uh, but the easiest way to start is to identify what the smallest possible piece in your program is. In this case, what's the smallest possible unit we have here? It's the customer class, and I even tell you in the instruction that that's what it is. But if we were looking at this project holistically, we think, okay, so we have some program giving them kind of like a terminal login, like a command line interface experience, and they're going to have 3 options of what to do. And like, let's say they decide to log in, then we need to go check their customer information and compare credentials. And the customer object should probably also hold what the balance for each customer is, because that's just going to be the easiest way to do it. Then we need a way to hold all these customers together. We're going to have a bunch of different customer classes, and these customer classes have to exist somewhere. That could be just a simple array, that could be an object dedicated to it. Probably better to have a whole object dedicated to it, so that way all of our lookup customer functions can be handled within the database itself. That way, we're really just assigning responsibility to singular classes. Uh, so yeah, let's start out by creating the customer.java class. Class Java, customer, and we shall go now to, let's see, let's do all our various public string first name, last name, private int age. Account ID is an alphanumeric, so that's a string. Private string account ID and PIN. And then private double balance. Okay, so this is it for all our customers. Let's go ahead and make a constructor. Customer. And then we're going to make the explicit constructor because we're never really just going to create a blank customer object. We're always going to initialize some kind of value to our customer object. So string first name, string last name, int age, string string in double. So we're going to take all these parameters. Last name, age, and this dot balance equals balance. All right, cool. So let's look at this. We've got a few private variables like balance, and we do know that within this program, the user should be able to withdraw and deposit um, and query their balance, right? So that means we need a way to see and modify this private variable. And whenever we need to see and or modify a private variable, what do we need to do? What does the class need to have?
A setter and getter.
Correct. So let's make some setters and getters. I'll do int double get balance. Public void set balance. Balance. Here. Okay. We also, when a user logs in, we need to check their compare their account ID and PIN, right? So what I'm gonna do instead, there's a few ways I could do this. I could make setters and getters, or I can make a public Boolean valid credentials in, and I can return this dot account ID equals account ID, and this dot pin equals pin. Remember, when we're comparing strings, we want to use the equals method in the string class, right? We don't want to use the equal comparison because that doesn't necessarily compare the literal string. So there we go. We've got this method here that is going to, anytime I go through a user's account ID and info, it's going to check what's a valid user. And I think that's it for the customer class. Am I missing anything? No. I think the age thing I had there just to exist as the age, just to have like a variable. I don't know if we actually use the age. You know, just to use it, we'll have a getter for it. That way I'm demonstrating all the age. So this way I'm demonstrating the idea that just because you have a private variable doesn't mean you need both a getter and a setter to it, right? And that sometimes we can use our private variables without having to actually use a getter and setter for it. We can just create a specialized, depending on our implementation, we can create a specialized function that'll use those things. So the one small modification I'm going to make is when it says print out our happy customers list, it's just going to, after it prints the name, it's just going to say comma age and their age. Yeah, I mean, like some of the stuff is just, you know, practice. Like after a while, you start coming up with like these little things, or like it really just takes you seeing someone else do it to do it. But I really try to limit lines I can. It's one of those things of another one of those like coding conventions that you do. It's usually considered, I don't want to say polite, but polite as a coder to make it so that other people reading your code don't have to like scroll up and down to read your code. They could just see as much of your code on one page as they can. That way they can read your code easier. But obviously it should still be readable. Some people I know complain a lot about this kind of thing. But you know, if you just read get or setter, you know what it does. Okay, so we were done with the customer class. Now let's create a database class that will hold all of our customer objects together. So if we have multiple customers, we're going to have multiple customer objects. What's a good way to hold that information? Should we maybe do something like customer C1 is equal to new customer yada yada yada, or who has better ideas? Like, what should we do here? What's a good way to hold all of our customer data in the database? Any ideas?
Well, personally, I would use an array list, but you said that's sort of like a no-no for the time being, so just use an array.
Exactly. An array is perfectly fine. So we'll say privates customer array database equals. Actually, we can even just call this customers. That way, the name is a bit more succinct. And we'll say new customer, and then Joe Johnson, age 45, account ID. Boom. I almost had it perfectly. I should have been looking at the sheets so I could have the so that I could like line up the data perfectly, and I could just like copy paste from the document. Whatever.
Too bad we can't set it up so it's reading from the actual like file.
Yeah, the easiest way to do this would have been to like just have a data.txt file, or like just call it data and then, or a CSV, excuse me, data.csv, and then, well, this kind of fucked it all up, but had everything separated by commas like that, and read the CSV. Oh no, I'm already pasting it from what do you call it? I'm already pasting it from the other place. But thank you though, Mohammed. Customer. Jenna Martin. Page 23. Account ID. That's pin. ICA balance. And maybe for like the purposes of the demo, I won't do the whole customers. I'll just do a couple of them. But you know, like I only did a couple, but you guys get the idea. So we could have this right here, and then we could say public database. I don't think there's anything else the database needs to hold. So this is just something I have to do. This I have to do for Prepolix Java version. Actually, no, because we're not having a constructor at all, it'll just default to a default constructor. It only gets confused when there's an explicit constructor for an object. Okay, the database class has this, so we should be able to get so public customer get login customer. So they're going to give us the string account ID and string PIN, and then for each customer current in our customers list, if current credentials. And we return current customer. So basically what I'm doing here, I'm returning that customer. Dumbass. Otherwise, we return. I'm sorry, we do need to do this because there is a chance that we go through the entire customer list and we don't find our customer. And actually, I think I feel bad that. Let's do a couple more of these customers. Barry Levine is 67. Account ID. Balance is that. And then there's his pin. Okay. So we'll just have these 3 customers that we can log in, which is not a big deal. And in fact, what we'll do here, we'll even do a prints. Actually, we'll handle that elsewhere. We don't need to worry about the user interface here. This is just a worker. This is just a worker method, so it just needs to do the work. It doesn't need to worry about giving output back to the user. That should be the responsibility of the person calling it, of the entity calling this to interface with the user. Like this class's responsibility is not to interface. Does not have any responsibility to interface with the user at all, right? Even through print statements, like. This doesn't need to have print statements. All it needs to do is check for a login customer. And the reason I'm doing it this way is what I'm going to do in the main class is I'm going to have a variable that just holds the customer that is logged in. That way, we can easily pass that customer around. And then when they log out, it's going to set it back to null. So we've got this, so we should make a worker class. The worker class should be able to perform the following actions: withdraw and or deposit a given user's account, display user's balance. Okay. This one should be easy. Worker.java, public class worker. We don't need any variables initialized. It just needs to do work. So public double check balance customer return customer.get balance. Okay, and then public void. We're just gonna call it change balance. Actually, we'll just make explicit withdraw deposit. Withdraw double amount. And it should pass the current customer entry. So this way we have a withdraw deposit method. Actually, yeah, we'll do withdraw deposit. That way it's more clear. But the other way we could have done this would be to just name this something like change balance and then feed a positive or negative amount to this thing. So if they were going to withdraw, we would give a negative amount. Like if the user said withdraw, we'd like initialize a negative somewhere, and then we get this. But it's going to be a little more easy to read, or just a little more base level, easy to understand if I do it this way. So public void withdraw, and we need customer.set balance is equal to customer.get balance minus amount. And then for deposit, we are going to do the exact same thing, except we're going to add. And we should actually have a thing here. We'll do it in customer. We'll say, when we say set balance, or here, we'll just take care of it in the worker. if is greater than or equal to 0. So, meaning we have the funds to make this thing without overdrafting, because we don't want to do overdrafting. Else, system at println insufficient funds. Deposit shouldn't have that problem because we can just put it wherever. We can deposit how much we want with no problem. All right. So we're going to create the main driver class of the program. And this is where the meat and potatoes comes in. So the way I like to do a driver class is because I hate everything in here being public static, what I'll usually do is I'll make a run. And I feel like I'm going to call additional methods here. And there are going to be a few things that I'm going to take additional methods on. So what I'm going to do is say new main.run is going to be in our main method, and then public void run. Put that here. So the body of the actual program will be here. This just allows us to get the program rolling. And I do this so that I don't have to declare static methods everywhere within the main method. That's literally the only way. Literally the only reason. It's better, in my opinion, others might disagree, to not declare static methods and static things in places you don't have to. So whenever you declare static, it should be for a purpose other than, okay, this is just a feature that I have to abide, right? Because there is a workaround for it. That way, when people see static in your code, it should be for a reason, in my opinion. That doesn't mean that like that's the end all be all. Driver class. Okay. System. We'll say, and we'll just have a method called public void print main menu. Just say system ln. Welcome to the bank. Do system ln 1. What were the 3 options? We should also have a. By the way, I apologize if something gets loud. I apologize if it gets loud. There's work being done outside the house, so I apologize for that. Can you guys hear me okay still?
You're a bit choppy. I'm catching like every third word.
Hello? Can you guys hear me?
Okay.
You not being able to hear me, has that just now started, or was that kind of happening the whole time?
It just barely happened. Like.
Okay.
Yeah, you sound decent now.
Okay, cool. Customer, current, customer, we'll call that. I'll just leave that blank for now. Sign in. To show customers list and exit. So one thing we'll have to do here actually within the database, because only the database can directly access this, we should print out all of our customers. I just realized that because we need to have 3 per line, let's just do, I can't be lazy about this, so I need at least 6 of these guys. Jenna Porter. Yeah, you guys might be able to like not hear me when they turn on the saw or like whatever it is outside. 1, 2, 3, 4, 5. Let's do one more. And then Robert Fisher, 19. Okay. Cool. How does it do this sometimes? This is so weird. So the nice, is someone like logged into my account and like they're fucking with my Replit? Because sometimes Replit does this where it shows me that there's like another user of my name logged in and working on this thing with me, which is kind of annoying. It's never done this. So unless like someone decided they're gonna hop in through my repo and fuck with the code, if you did, please don't do that. Thank you. Anyways, or it could just be a weird bug. I don't know. What was I gonna do? Oh yeah. Public void print customer list. We'll just do that in here. Wait, this is the worker class. My bad. I meant to do that in the database class. Public void print customer list. For each int count equals 0 for each customer and customers. I'm going to say system out print I'll just do print f. So string. I'll just put these age, digit, and tab. And then for this, we'll have parent dot first name, parent dot last name, parent dot get age, and then count plus, and then we'll say if count equals 3, then we're going to system out println. We're going to put a new line, and then we're going to say count equals 0. So that way, when we print out our line, when we print out our customers, it's going to print 3 at a time. And then when we get to the last guy, or when we get to the third guy, we're going to say, oh, okay, we've already printed out. Oh, this should be. Or hold on, it's going to start at 0. Then I was going to print out the first guy. 1, I'm going to print out the second guy. 2, I'm going to print out the second guy. Increment it. Yeah. So it should be. When we get to the third count guy, meaning it went 0, 1, 2, and then 3 should start on a new line, that's going to do that. Cool. So let's give this a whirl and just say database db equals new database. Actually, we'll do this all for the worker. I'll even put now we'll just do the main. Okay, the main driver. New database db dot show customer print customer list. So let's go ahead and run our program one time and just see what we've got so far. Perfect. Awesome. It prints out our customers just as we want it. And you know what? Just to kind of, yeah, this is fine. That's fine. I was going to think about putting a 7th one, but it's fine. We know that it works. Cool. So we're going to say print main menu. Welcome to the bank. And we need to initialize a scanner. Import Java util scanner. And then we're going to say scanner C equals new scanner. I got a DB object, print main menu. While true, we'll keep an infinite loop. Print main menu. Int command equals scanner dot sc dot next int. And then we'll do a switch statement. Actually, you know what? We don't even have to do that. Look how much more efficient we can be, guys. The user is going to give us an input, and we're going to switch it immediately. Case 1. Do the sign-in process. Break. Case 2. db.print customer list. Break. Case 3. System out. Println. Goodbye. And then we'll system.exit 0. 0 usually means you exit without errors. And say break there. And then we'll say default system out println command not recognized. Please try again. And have you guys already learned about try catch blocks error handling?
Yeah, a little bit.
So what I'm gonna do here is I'm gonna say try, because we're big boys now, and we're going to prepare for the case of what if our user gives us something that isn't, and you don't need to have this in your code. I'm just doing it for demonstration purposes. I do not expect you to have a try catch in this code because it wasn't asked, but this is a good opportunity to demonstrate. Input mismatch exception. Name it E. So if we get a error, so what we're gonna do is we're gonna try this. Okay, we're gonna try this block. We're gonna get the user's input. If for whatever reason the user gives us a, let's say they say A here instead of giving an integer, then we're gonna get an error, right? Because that's an input mismatch. We're expecting integers, but they don't give an integer. So if we encounter this specific exception, we're gonna put out a message to the user that says system at println something went wrong. Please try again. Or sorry, please give please choose an option 1 through 3. Please enter a number. Let's say that. And we'll even say catch just a exception. This is just a general exception. E. Say system out println something went wrong. Please try again. Okay. So just a quick recap on exceptions. Try catch blocks are really, really good for preparing for things in your code that might break. So what it'll do is by default, it'll just run this. And if the user doesn't do anything that's going to throw some kind of exception from Java, then it's gonna send this. And by the way, then it's gonna just run this normally, and it's gonna once when it gets to the end here, it's gonna ignore the catch blocks, obviously. Quick note: every exception, every error thrown by the compiler in Java is called an exception. It's part of the exception class. Then there are other classes like input mismatch exception or index out of bounds exception, array index out of bounds, stuff like that, that'll throw up errors, that'll throw up their own specific exceptions, but realize that all exceptions at their core are exceptions. So what you should do when you're doing your catch blocks is if you have specific cases in mind of things that could go wrong, like in this case, one specific thing that could happen is the user gives us invalid input. Like they give us a string when we're expecting an integer. Instead of just having the program crash there, because that's what would happen, the program would crash and you'd encounter a runtime error. Instead of having a crash, we're going to tell the user, hey, yo, please give us an actual number. And then because of where the try catch block is, we're just going to go back to the start of the while loop. And what we're going to do here is, so excuse me. Does that kind of make sense? Sorry, before I go on. Did that make sense to you guys, the whole exception thing? Was there anyone confused by it? Want me to explain it again?
It was clear.
Okay. So let's go ahead and fill in this part. So we've got the print customer list. So if they signed in, we're going to say, okay. Oh yeah, I could do that. System error. That way we differentiate our error prints with just usual output command prints. So let's see. So we're going to do the sign-in process. So if they want to sign in, system out println, enter your account ID. I'll just say system print. That way the user will print on the same line. This is just a formatting thing that I have. It's just not anything. There's no functional reason to do it this way. String count ID equal to sc.next line. And then because I'll hit enter, it'll print to a new line. We'll say system out print, enter your pin, string pin equal to sc.next line. And actually we'll say while true. Sorry, I just realized something here with formatting. After the loop, it should still system out. Do a new line. Sorry, I'm just trying to think of because I'm coding on the fly, I'm trying to think of a good way to do this. So they're gonna, once they log in, we're gonna have our current customer. I'll say while current customer null. So while this is null, because by default, and we'll even just be explicit with it and say this is null. And then we're going to have log user. How to do this? So we want to try to log in the user if And we'll just pass the scanner in. Okay. Turn. Turn. I should also probably pass in the database. Return db dot get login customer account ID and PIN. Cool. So we've got a way for the users to log in, and we're going to say over here, while current customer equals null, system at println, couldn't validate user, please. Actually, you know what we'll do? We'll say if current customer equals null, system at println, user not found. I'll even print it in the error prints, so it prints in red. Scanner and DB. Okay, cool. This way, we have kind of a natural loop going through the thing. Once when we get a user that is logged in, once when our user logs in, then we switch to the other menu, the logged in menu. And for their PIN. Hold on, they can log in. If they choose to log in, the program will prompt them if they want to log in using their bank account ID or their full name. And we're just going to go ahead. This was a really dumb requirement that I had, and it was just makes your program so much uglier. If you did it, great. If you didn't, fine. I'm taking out the requirement for where you have to ask the user if they want to log in using their full name or their account ID. I think it's just a silly requirement to have that just makes things unnecessarily complicated. Chosen to log in, ask for their bank ID, and then for their PIN. Okay. And because I made that change, I'll give an extension for this. Well, I can't give an extension because I'm showing you guys how to do it right now. But yeah, if you made the change, if you put it in with like, what do you call it? I can't think. Holy shit. Oh, if you made your lab program according to the initial lab that I had written here, where you had to ask them for if they want to log in using their name or their bank account ID, that's okay. You're not going to lose points. But if you didn't implement that, that's also okay. Because again, upon reviewing it, I think that's a really just unnecessarily complicating feature of the program, and it just doesn't need to be there. It doesn't really like prove anything that you know anything deeper or not. It's just very annoying and a whole bunch of extra if conditions to something that can already look kind of messy. Anyway, so the main loop. So while the user is logged in, while true will say, this is going to be the core loop. And we'll have public void print customer menu system at println welcome I'll put another name. It's gonna be easier to do this in printf. Welcome. First name, last name. What would you like to do? New line. Current customer dot first name. Current customer dot last name. My logic in this is not going to be 100% sound. One of the things I just realized you guys have to kind of fix here in your programs, that it's not going to happen in mine because I'm tired and not thinking through things, is I don't really have a proper structure to go between being logged in as the customer back to being logged out, being logged in as a customer back to being logged out. Here's what we'll do. While true, this will be the main loop. I'll say if current customer is equal to null, no user menu. I'll just call it main menu. Else user menu. And I'll have public void main menu. Okay. Scanner DB, scanner SE, database DB. And then here we'll say while true, because we'll just keep going until the user decides to log out. While c dot next int so less than 4. And if he ever enters in 4, actually we'll just say while s is not equal to 4. And then when he enters in 4, we'll say the moment he enters in 4, we'll say current customer is equal to null. And then that will put us on the next iteration back to that. Cool. So, where's the print customer menu? System app println. We'll just call this print user menu. That way our names are consistent. Balance statement. System app println. Make withdrawal. Make deposits. That'll be 3 and then 4. Blocks. Actually, we'll call this input. I'll say int input equals 0 by default. Doesn't really matter. Actually, we don't even need to do this. We can just do while true. Hold on. True for the pause menu. Switch. C.next int. Case 1. Case 2. Case 3. Case 4. Hold on a second. We could just copy from this. This whole try catch block. One, two, three. Case 4. Break. If they're going to log out, we'll say current customer is equal to null, and then return. So we don't even need the break statements. So if they say 1, that was balance statement. System at printf current balance. And then we'll just say current customer dot get balance. Cool. Number 2, make a withdrawal. System at print enter amount to withdraw. Double amount is equal to C.next double. And make sure there's a new line. Actually, to just clear the buffer, we'll say that. If you guys remember from like earlier in the semester, whenever you go from switching whenever you use something that's not next line, there's going to be a hanging new line carriage left over. So I'm flushing the buffer here because it'll be easier to do it that way. Just make sure I empty the buffer every time that I call something that's not new line. And then make a deposits. Or say new worker dot withdraw current customer and then the amount. And actually number 4 is going to be, or number 3 is going to be like exactly the same amount to deposits. And the only difference is here you call the deposit function. And then in case 4, they log out. We make the customer null. We say return, which means that we return out of this function. And then we're back at the top of the loop of the main menu. Back with the main menu because current customer is now null. Okay. That was a lot of code. Let's go ahead and run it because now we get to the wonderful part where we have to debug this and make sure there's nothing wrong. What's going on here? Oh, time to start the debugging process. Isn't coding fun? Solving problems, creating problems. It is relaxing. I agree. What do you mean? Dude, these are 2 different cases. These are not the same symbol. Come on. Come on, Replit. I'm going to be so mad if I refresh this page and like half the code that I just wrote is gone. It's only when I'm demoing for you guys too, by the way, that it's like this slow and annoying. Then again, I never like use it to write like full programs. I usually use this to just test like unit test little things, but I figured recently I'd like do it on here because this makes sharing the code so much easier, and you guys having like everyone having the same environment to run the code in, like guaranteed same environment to run the code in, is nice.
Yeah, part of your problem could be that because Zoom is also using your data, while this is
Yeah.
also trying to contact a server, you're having sort of issues that way.
Could be. There's also like other people working in the house going on Zoom and stuff too, so
Very true.
could be a lot of like upstream bandwidth. What happens if I just say, let's refresh this actually. Oh, refresh the page. Oh, holy crap. What a dumb reason to have an error. What a dumb thing that I did. End user menu. Really? Huh, well, today I learned something, I guess. Apparently in cases, these two cases, variable names aren't or like initialized stuff aren't unique from one another. Okay. Show customer list. Sign in. Wait, what? Oh. Doy. Here's what we'll do. Enter your account ID. Okay. Should work now. Sign in. Enter your account ID. Let's log in for Mr. Joe Johnson. Welcome, Joe Johnson. What would you like to do? Let's do a balance statement. Oh. And there's just a minor thing, but I'm going to format the %F. So it rounds to the nearest two decimal places. Or it only prints the two decimal places. It doesn't actually round. It just chops off the rest. Make a withdrawal. 420. As we can see, the balance was modified indeed. So then we log out and we exit. Goodbye. Cool. Our ATM app works. That was a lot of code. We've been sitting here for a little while. Do you guys want to take a 5-minute break, just stretch before we go into the next thing? Any questions, I guess, before we break? Any questions about the ATM app?
Can you just share the database.java screen really quick while
Yeah,
we're
sure.
on break? Okay, thank you. I just want to study it.
And I'll go ahead and I'll publish this. I'll publish this on after class. Any other questions about, in terms of implementation, how I went about it? Any observations, anything like that? Okay. If there's no questions, let's go ahead and take a break for 5 minutes. I'll see you guys all back here at 11:11. Okay. So the main thing I wanted to kind of do today was, and this is going to be across both classes, was build a small little Pokedex game. So I have a few notes for it written up over here in Notepad. Go ahead and just reload this page, close the ATM program. The way the game's going to work is I'm going to make a bunch of tall grass nodes, and each of these nodes is going to have a chance to randomly generate one of these Pokemon, one of these 4. I'm just going to have these 4 initialized in an array, and then this chance here represents my chance to catch it. So the game is basically, you don't have a Pokemon, you're just trying to catch Pokemon, you're in like a safari area, and I'll keep it on an infinite loop just to make things easier, just to make creating the map easier. But yeah, so I already kind of demonstrated a couple weeks ago how to create, a node that can a 2D map using a 2D array. So I'm going to kind of breeze through that. But basically, this class and the next class, I'm going to try to create this program. So probably because we only have like 40 minutes left in class, less than 40 minutes actually. Because we only have like a little bit of time left in class, all I'm really going to try to get done for this class is building the actual like Pokemon objects and getting that like pieces ready to build a map with. And then in the next class, I'll kind of go in more detail about each one. So there's not going to be any hard set encounters. Each map is just going to have a chance to spawn each node. I'm just going to assign a random integer value to it, or a random number to it. Is going to have some random chance to generate a Pokemon, and yeah, we're gonna do it that way. Java math random. I just want to have that up for reference. And then are equal to 0 and less than 1. Okay, cool. Cool. So here's how we're going to do this. First, we're going to go create a Pokemon class. Public class. Pokemon. And we'll just say private string name and private double chance public string description. And I'm going to go ahead and create a constructor public Pokemon string name double chance string description. This dot name equals name. This dot chance is chance. This dot description is description. Okay. Getters and setters public string get name return name public double get chance return chance. Okay. Create a basic Pokemon. Next up, I'm going to create a new file. Tall grass. I'll just call it node. And each node is going to have a that's annoying. Can you guys hear me over the construction sounds?
Barely.
Yeah, sorry.
It's a little staticky.
I'll move the microphone right here, so hopefully you guys can hear me. Is this better or still like super staticky?
It's a little fuzzy, but we can still hear you.
Okay. Yeah, it's just because like that thing is super loud and it's literally like right in the hallway outside my room, so I apologize. Let's say let me get a public double chance
actually, public final double chance is equal to new or math dot random. Cool. We should import Java-lang math. And we will say public boolean check if Pokemon. We're gonna return math dot random is less than or equal to the chance. So we're gonna generate a random percent chance, like a double chance to encounter a Pokemon here. And then, so like, let's say we generate a 0.9. That means there's a 90% chance of encountering a Pokemon here. And then we're gonna roll again, meaning there's a, mathematically, there's a 10% chance that this returns false, meaning there's a 10% chance that we don't encounter a Pokemon here.
So,
yeah.
Sorry, just dumb question. Also, good to know that I fixed it. Apparently, I kept trying to make comments previously, and my microphone came unplugged. So,
okay.
Anyways, so what I was gonna ask is, so is that just for the individual Pokemon, or is that for encounter any Pokemon at all?
This is per node. So we're going to walk around a map of a bunch of different nodes. And if there's a node in this Pokemon, or if there's a Pokemon in this node, excuse me, this is what tells us, hey, pick a random Pokemon for the user to encounter.
Okay. That makes more sense. I was afraid that it was like some individual random for each one. And if you got some weird bounding where they don't match up, you could end up having one Pokemon stomp on another.
No.
Yeah.
I'm going to say private Pokemon local Pokemon is equal to null to start. And all the stuff that I'm doing here is in lieu of having a default constructor. You could also just have something like public node is the default constructor, and we'll say chance is equal to that. Oh. Obviously, we have to remove the final here, and then local Pokemon is equal to, or is equal to null. There we go. Cool. And then public string get valid moves. Oh no, that should be in the map because the node doesn't know what the valid moves from that node are. Okay. Map.java. Public. What time is it? 11:20. Okay. So I can probably create the map, and then that'll be like the last thing that I can probably do in this class, and the rest of it I'll have to do in the next class. So definitely I'll post the code when I'm done, but definitely, like, if you guys are not able to just understand the code, definitely encourage you to check out the video for the next class as well. It can help you guys out. And I hope you guys don't mind how I've kind of been doing the classes, like pseudo asynchronously these last 2 weeks, that I've just been like live coding, really one session across 2 classes. But yeah, I find that at this point in the class, it helps to have these like very involved, like in-depth demos. And unfortunately, I just don't have time to do it in a single class, or like review the homework and do it in the same class. Anyways, on we go. Private node map is equal to new node, and let's make it a 4x4. Yeah, it'll just be a 4x4 map to keep things simple. And then all these are just going to be simple nodes that are using the default constructor. Perfect. All right, I'll say public map. Copy that. Cool. Oops. Here we go. So we've initialized the new map over here. And then we'll have a, we'll have private user X, user Y. User X equals 0, user Y equals 0. All right, I'll only have to be two separate. Have to be with semicolons. Okay. Cool. We've got our default constructor set up for the map. The method map and type map can only set not public protected. What? Oh my God, private hints. There we go. All right. So public string. Yeah, X and Y's for coordinates. Valid get valid moves. So string moves equals new string up to 4. If user X plus 1 is less than the focus on the X. Yeah, so the X is actually the inner one. This is kind of where like coordinates get messed up because of how 2D arrays work. This is actually your Y, and this one is your X. So I get to think of it in that direction instead of rows and columns. So is less than map 0 dot length. Then we say I equals 0, moves at I is equal to, that would make it east. Actually, I'm gonna just make these in a single line like that. 3, 4. Oh, wait, hold on a second. I just realized. Nope, can't do that because these are also gonna I plus plus if they add something in. So if X minus 1 is greater than or equal to 0, then we can go west. If user Y plus 1 is less than map.length, then we go south. And if user Y minus 1 is greater than or equal to 0, then we can go north. And then we return moves at the end of this. Okay. So we've got our moves. And let's see. How do you know whether map length or 0 for the bounds? Because that's a good question. So remember we said that the inner, if we think about how the Let me pull up Paint. So when we have an array, a 2D array of rows by columns, this kind of creates this like grid of, you know, some number of rows or some number of columns, and then and I'll actually make this red. So some number of columns and then some number of rows, right? So if we want to go east, moving east is column plus 1, right? Because over here is row 0, column 0, and this is row 0, column 1, right? So we added 1 to this. So we know that in any given, whenever we're heading in this eastern direction, the maximum we could go east, the maximum index here is C minus 1, right? Because that's always the max. Like over here is the max index is row minus 1, row length minus 1, column length minus 1. Because remember, row and column are lengths, right? When we declare the array, row and column are lengths. But we know that the maximum array, the maximum index of the array is always going to be maximum index of the array will always be length minus 1. Do you remember that, Mohammed? Does that kind of make more sense why we like, let's say we want to go south, right? South just means we're adding 1 plus 1 to the row, right? Now here we're in row 1, row 0, and then if we, you know, dot all the way to the end here, the maximum index for the row is the row, or the maximum index for this side, the y, is row minus 1, right? That's the maximum index. So if we want to, but if we want to say, like, let's say we're here, let's say we say here at 0, 0, we want to move west. Well, we can't, because if we move west, meaning we subtract 1 from our column, we can't do that because then we're indexed out of bounds. That's kind of how I know map length and 0 for the bounds. Does that kind of make sense? Same thing with north here. If I try to subtract 1 from the outer array, then that's indexed out of bounds. So we got all this. We've got our valid moves. And then we'll say public void move user string direction switch direction to uppercase, say case north, case south, case east, case west. So then if we decide to move north, then we say user y minus equals 1. Break. If we want to move south, user y plus equals 1. If we want to move east, user x plus equals 1. And if we want to move west, user x minus equals 1. And then we'll just have a default, not a valid direction. System at okay. So we have something to update the user. And then when we update the user, we're going to say, oh, I should also create a bunch of Pokemons. Pokemon. Pokemon. And we're going to just copy from this notepad that I have. So name is Pikachu. Oops. chance is 0.65. And then description. Geodude. Chance is 0.45. Description. That's. What's this? Can only be using the initializers. Okay. So we'll just move this over here. I'll say new Pokemon. Squirtle. Chance is 0.5. Description is that. And then finally we have Butterfree. New Pokemon. Chance is 0.25. Description is this. And then we'll say public so the user's going to move, and on each move it's going to say public check for Pokemon, return what did I name it? Map at user Y, user X dot check a Pokemon. And if that returns true, then going to public void counter Pokemon int I return how do we do this? Because what I had in mind for the program is anytime you catch a Pokemon, you will here actually it will do. Say no. So what I'm trying to do is if you ever catch a Pokemon, it's gonna work like the Pokemon game, right? In Pokemon, when you catch a Pokemon, it gets added to your Pokedex. And like instead of just seeing it as a you know, seeing it by that name, you so that means we have to have a Pokedex object actually. And then we'll just have a basically what I'm trying to do is the idea of the game is you're going to walk around through these nodes, you're going to encounter Pokemon, and you're going to try to catch them. You're going to try to throw a Pokeball. You're going to have the option to throw a Pokeball or run. And if you throw the Pokeball and you catch them, and you just kind of be able to like throw Pokeballs until you catch, or maybe I'll have some kind of feature where they run away. Yeah, so Pokemon that have a high chance of being caught will also have a high chance to run away. Public Boolean try to run say turn chances less than or equal to, or return math. All right, that's not here. Hold on. Where did I have the math.random? Is it in math? Oh, yeah. Over here, we check out this Pokemon. Somewhere in here, I'm going to have something that'll, try to handle like the Pokemon trying to run, the Pokemon trying to, actually, I could do that in the combat loop. That would probably be the best place for it. So the main program is going to be just us traversing the map. And then when we break out into combat, I'm going to have a separate class responsible for that. Okay, so the Pokedex. Public or private Pokemon encountered Pokemon is equal to new. Let's say the Pokedex has space for 20. It can hold up to 20 Pokemon that you've encountered. Okay. And then what it'll do is public Boolean check if encountered before Pokemon for each encountered Pokemon for each entry in the encountered Pokemon list, if Pokemon.getName equals entry.getName, then we turn true. Otherwise, we just go to the next. And if not, we then, if we finish the loop and we haven't returned true, then we return false, meaning we haven't seen this Pokemon before. Okay. So whenever we encounter a wild Pokemon, we want to see public void add entry Pokemon, and we'll have a int I equals 0. So Pokemon at I is equal to Pokemon, and then we increment the I. Okay. And actually, just to be safe, I'm going to make this a static, private static, meaning, so I've kind of touched on this a little bit before, but this means that this int I is static, meaning only one instance of it exists. So even if I make multiple Pokedex indexes, they will all be at the same I. So let's say, let's go back to Paint for this. And I wouldn't do this in the program, but just to illustrate the concept of it, suppose I have Pokedex A and I have Pokedex B, right? And I put 3 entries. So this is I is 0, I is 1, and I is 2, okay? So right now, I is equal to 2. I've got 3 entries here. And then I start writing in Pokedex B instead for some reason. That means over here, we're going to start at I is equal to 2. And like when we encounter a new entry, we're going to put it at I is equal to 2. And, or technically it would be I is equal to 3 because that's where you put the entry 2. It becomes, we increment it, so I is 3. So this starts at 3, 4. But in this Pokedex, 3 through 4, and like let's say after the 4th one, we go, after index 4, we go back to here. Then we start at index 5. on this one. Does that kind of make sense? Does that illustrate how the static thing works? Notice that here, here, and here are all like empty. If I ever go back to if I ever printed out this array, there's going to be certain parts of Pokedex A and B that are empty because I've been flipping back and forth between the two. But the reason that it happens this way is because this integer I is static. So regardless of whatever instance of Pokedex you're in, whether you're in instance A or B, it's still going to, the integer I will be shared across all instances of this class. Does that make sense? Any questions on that concept? No? Cool. All right, awesome. Let's see. We got a way to add entry. And I believe that should be it. So from here, we're just going to be, is going to be stuff that I have to write for the next class because we are out of time, unfortunately. Yeah, I'll continue to work on this for the next course, for the next class. And yeah, so the recording is going to be converting. Hopefully it doesn't screw up. There was a weird error that happened last time when I started recording for the other session while the other one was already processing, but hopefully we don't have that same error. So I'm going to go ahead and stop the recording here.